Hi everyone, and thanks for joining us today. I see that some folks are still signing in here, so why don't I hold off for a few seconds here and we'll get the presentation started shortly. Just give me a couple minutes. All right, so maybe that was more like a few seconds than a couple of minutes, but I guess that's okay. We'll get started. I first want to review today's agenda. We're going to start out with a short introduction to Done Solutions Group, and then we're going to dive into the topics at hand. We're going to look at the need for data modernization, and then talk about the synergy between the data lake and the data warehouse. Once we're done talking about that, we get right to a demo where we show you how you can build a data lake and a data warehouse on Snowflake and see some of the benefits of doing so. And finally, we'll wrap it all up with a call to action. Done Solutions is a digital commerce and business transformation consultancy. We bring velocity to our clients, and we think of velocity as two components, the combination of speed and direction. Done Solutions helps our clients achieve speed by automating business processes, and we provide direction by using advanced analytics. After all, if you're going to go somewhere fast, you may as well go fast in the right direction. We align with organizations to optimize their unique processes and help them discover the most profitable routes to business success. Done Solutions is headquartered in Chicago, and we have offices in Minneapolis and Bangalore, India. Our hybrid model allows us to bring value to our customers. Velocity leads to the velocity virtuous cycle. Done Solutions' velocity virtuous cycle supports an organization's digital transformation journey. The basic premise is that automation feeds data to analytics, which then feeds insight or prescribes actions to be taken back to the automation process. It's a feedback loop that keeps the whole process running efficiently. All right, so let's get into this now, and let's talk about the need for data modernization. If you're in the industry, it's no mystery that today's data consumer is very demanding, and they have a good reason to be very demanding. Turns out that 80% of consumers need KPIs and operational data in order to do their job, so the data warehouse is ideal for them. Now, 15% of those consumers are data analysts, and they do more analysis. So they may use the data warehouse as a source, but they often dive back into the source systems to get more information to further along their analysis. An obvious challenge here is how do you give them access to that raw data that came from the source systems without impacting those source systems? So that's something to be concerned about. And our final group of data consumers are the data scientists that do very deep data analysis, and they can't get enough data. They're voracious data consumers, and if you can give them access to data, they would really appreciate it. Now the problem is, much like the data analyst, how do you give them access to this raw data that's in the source systems, let alone data that sits outside of the source systems that may be gathered from other sources? So where did this change in data appetite come from? Well, there's some macro trends that we can talk about that have changed the landscape. First is the explosion of smart devices and IoT devices. So smartphones, tablets, and IoT telemetry devices generate tons and tons of data that we can actually use and can be harvested to optimize and to make more intelligent decisions. Then came the explosion of data visualization tools, and that market is saturated. There's so many options here. There's subscription-based tools, on-premise tools, software as a service tools. They're very easy to use, they're very powerful and compelling. Now that said, I should also mention that data visualization tools also expose something, the need for clean data, the need for data that actually made sense, and that comes into play a little bit later, but keep that in mind. And the third macro trend that I want to mention is the analytics hype or the analytics excitement. Everywhere you go, everyone's talking about analytics and how important they are. Regardless of whether they understand how it works or not, the fact is that everyone talks about analytics today. So it's all about data. But where does that data come from? How do we store it? How do we present it to people so they can consume it? Two options we're going to talk about is the data warehouse and the data lake. I often hear or read about discussions around the implementation of a data lake to replace a data warehouse, or deciding on whether to use a data lake or a data warehouse. I'm here today to tell you that it's not an either-or proposition. Data lakes and data warehouses serve similar purposes, but for different situations, and they must work together to support the modern BI and analytics needs, to support the modern data consumer. Before I tackle how data lakes and data warehouses work together, I'd like to set a baseline understanding, and I'll start with the data warehouse. The data warehouse is the data repository that you go to for highly processed data, highly structured data that serves to measure business processes. Think metrics and KPIs. While it does provide atomic data to support analysis of the business metrics and KPIs, the scope of the data warehouse is measurement of those known and well understood business processes. Now that said, the warehouse does support descriptive analytics. Think dashboards and reports used to run the business, to ask questions such as, how did we do? How does this period compare to last period? At Done Solutions, we've implemented hundreds of data warehouses to do just that. And I'm not trying to imply that the data warehouse is limited to descriptive analytics, but this is where the strength of the data warehouse lies. Let's switch gears and talk about the data lake. The data lake is also a repository of information, but unlike the data warehouse, the data lake is a repository for any data in any form, structured, unstructured, or semi-structured, that has not been processed in any way. The data sits in waiting until someone comes up with a reason to use it. The point is, it's lots of diverse data in its raw form, and it's available for many users. Think about the data scientist who needs to find patterns to explain outcomes using ML. Think about the analyst who has to determine root cause. Bottom line, the data warehouse supports one version of the truth for KPIs and metrics used to measure business processes, while the data lake supports data exploration for various audiences of unprocessed data for insightful discoveries. So let's take a look at some of the differences between data warehouses and data lakes. The data warehouse typically stores highly processed structured data. Its processing is based on schema on write, and it's typically stored in an RDBMS or a columnar database. It's a little less agile and requires a lot more work to incorporate new data elements and new use cases into the warehouse. The intended audience is typically business users and business analysts. The data lake, on the other hand, is based on structured, semi-structured, and unstructured data. Its processing is based on schema on read, and you may store this data in blob storage or S3 or even Hadoop. It's very agile, easily scales, and supports huge quantities. And then the intended audience, typically data scientists, analysts, and researchers. So now that I've differentiated the two, let's visit the question, how do they work together? Data warehouses and data lakes support different use cases, but it's not hard to imagine that there are use cases that need both highly processed data and raw data. For example, IoT data stored in a data lake could be summarized in fact tables. You can enrich metrics and KPIs with supporting raw data that further describes the transactions. You can use it to forecast more attributes than are available in the data warehouse, and you can combine sentiment analysis with descriptive dashboards. Combining structured data and semi-structured data to perform analytics is challenging. It's challenging from a user's point of view and from IT's point of view. The challenge comes from both fronts. From you, the analytics user's point of view, getting the data and integrating it is difficult and time-consuming. After you get access to the data, you're doing lots of manual ETL and ELT to get structured data and semi-structured data into a state that you can use it for analytics. And usually that means the creation of rogue databases and spread marts. And even if you're very clever, much of this data preparation and integration must be done each time you get fresh data, and that's no way to run a data-driven organization. From IT's point of view, the effort and cost to maintain a scalable environment that can support data warehouses and data lakes is daunting. It's also challenging to expose these various sources in a user-consumable way. IT's time is split between supporting users and business requirements and supporting infrastructure. To be clear, supporting users and business requirements is far more valuable. The demonstration we're going to show you today lets us see how Snowflake can help on both these fronts. Speaking of demonstrations, I'd like to turn this over now to Sunil for the fun part.
Thank you, Jose. Hi everyone, this is Sunil. I am Analytics Architect at Done Solutions Group. I will demonstrate data lake and data warehouse built using Snowflake Cloud Platform. This is typical on-premise data warehouse architecture, where organizations build ETL systems to extract data from different sources, transform the data into dimensional model structure, and build reports and dashboard on top of it. Let's see example of one of the on-premise data warehouse. This is on-premise OLTP database, which contains data from different source systems like sales, HR, production, etc. This data get extracted, transformed, and loaded into this warehouse. This warehouse consists of different dimensions and facts which are used by different reports and dashboard. This is sales dashboard built using Power BI. This is connected to on-premise data warehouse. We need our data warehouse and reporting system back as it to support the business users using dashboards and reports. We have created a data warehouse in Snowflake with the same structure and populated it. Now, as Jose described, demand for data by different user types like business users, data analysts, and data scientists grows in the organization. In order to fulfill their demand using on-premise data warehouse system, we need to add data sources to existing data warehouse, change ETL code in order to get newly added sources, as well as change data model if required. Over the period, data warehouse system will face scalability and performance issues due to increase in data coming from various relational and non-relational sources. This will result in increase in data processing time, which eventually leads to stale reporting. Challenge is, on one hand, we need to address existing business users without changing their method of interaction with data and make it available on time. And on other hand, we need to support increasing data volume, capture uh, of data coming from variety of sources, as well as fulfill the other data users like data scientists and data analysts. So what's the solution? In order to transit from on-premise data warehouse system to modern data analytics in cloud, we need to capture and store the data from all source systems into data lake and build a different data processing jobs on top of it. Let's see a demo of pre-built data lake and data warehouse. As a first step, we have extracted all the source system data into data lake, which is built on Snowflake platform. This is Snowflake Stage area where all that source systems data being stored in a respective folder based on their domain. Here we have captured all the data as is in a raw format in files. Then we validated and store the data dynamically into the tables, Snowflake tables on top of stage files. This data is now ready for consumption. Since data is getting stored in Snowflake Cloud Data Warehouse, we can implement role-based security and data governance policy easily. Let's move further to next step. Along with OLTP data, we have captured and store a semi-structured JSON shipment data into data lake. Remember, there is no storage limit to data lake. We have capturing shipment data on an hourly basis and storing it into data lake. Here is a folder structure look like in a data lake for all the shipment data. Next step is to load and query a JSON data. Snowflake support parsing of semi-structured data like JSON. This is our shipment JSON data look like, which contains a tracking number for each order. In this example, we have built a table on top of JSON files from a data lake, which you can query a table or you can join the JSON data with the other tables in order to get the required results. For business analysts, they can also run their queries to get their matrix directly by querying a data lake. Here, they can they are running a query to get an average days to deliver an order after it being placed. Now we need our data warehouse and reporting system back to continue supporting business users who are using reports and dashboards. We have created a data warehouse in Snowflake using same dimensional model. Only difference is now we are populating data from data lake. Then we have updated sales dashboard data source and pointed it to Snowflake data warehouse. This gives us the same functionality to the business users as they were using it earlier. However, it's more performant now. Since all the data points are being not captured by data warehouses, data scientists usually connects to all the source systems to get a raw data and then prepare a model on top of it. Since now all the data is available in a single data lake in this area in a tabular format, they can prepare the data and create a model and also store output back to the data lake or data warehouse. This SageMaker application connected to Snowflake data lake and connects customer and sales data to predict the potential buyers and store the results back to the data lake. Marketing team then uses this data to reach out to customer via different channels.
Now let's wear a data scientist hat. I'm going to demonstrate you how data scientists can use data lake built on top of Snowflake to read data from it, create some models, and then output that model's predictions back to Snowflake. These predictions can be used by other users like business analysts or business users. So I will first show you how Snowflake environment is set up, and then I will show the process that data scientists follow to create data or to prepare a data to create a model. Then I will come back to Snowflake to show you how data looks like and how other people can see it. We already know how we have set up environment in Snowflake for data lake and data warehouses. In this example, we are going to use demo TSG database in Snowflake, and we'll be focusing on table called sample transaction, which contains historical sales data along with customer information. So I am now going into my data scientist environment in AWS SageMaker. I will demonstrate how this model is designed where we are reading data from Snowflake, making some predictions and storing that prediction back to Snowflake. So here is my SageMaker environment. First, I am importing some packages to use it for later use. And then here I am creating my connection to Snowflake account and reading sales transaction data. In SageMaker, it's very easy. It's just a SQL query to read a data and have all the data ready to go from Snowflake. Once I get the data inside, it's then pretty much same like data scientist environment to prepare a data sets, create models, and get predictions output. So here I prepare my data set. In this case, I am interested in customer transactions and I will predicting based on historical transactions. How likely each one of these customers are going to buy something in the future, and also will be assigning a value to each customer to know how valuable customer will be in future. So here I am taking all these transactions and creating some features. This is what we call future evaluations. So right now there are only few features I'm looking into, and then I create model settings on these features to create some likelihoods and projected number of transactions that they will buy. For this case, I will be projecting number of transactions in next 365 days. Probability of how likely they will buy into the future and how much they will buy. So it's hard to look at these numbers so as data scientist. It's important to visualize this and see how many customers are likely to buy, how many are unlikely to buy. So we see almost 50-50 split between people who are not getting, who are not going to buy in red and people who will buy in green. And then what we are going to do next is to divide these customers into buckets, like people who are certainly not going to buy, people who are going to certainly buy, and then we have some people in yellow for which our model cannot get a good read either. So what we want to do is we look at them from these groups and see how valuable each bucket is. And you can see with this output like this, how other users of data like business analysts, manager, departments will like to use this data. And then what we are going to do next to divide the customers into bucket. So what we want to do is we look at them from these groups and see how valuable each bucket is. So for example, if you are in a marketing team and you would like to know which customers are in which bucket because you want to target the people who are certainly like to buy and maybe people who might provide a value, but definitely not to target the customers who are not going to buy from you anyways. So you will certainly group them and then target the people who is going to provide a value to it. Once you have that output, it's very simple to reading the data. Just to show you what is it look like. Here is the data. Now we have demographics of the customers, we have probability, and then their predictions and also their group with the value. So with all these predictions, we want to put our predictions back into Snowflake environment so that other users can use it. This is very easy to do with just a single line of code. Let me go back to Snowflake environment and you can see here, let me refresh it. It's just been updated. So now we can have our predictions in Snowflake, which labeling each customer and their respective groups and any other users who has access to it. And it's easy to read this data and just easy as a data scientist can read to create these predictions. Now we can use this data for more actionable insight later. Once the data is in Snowflake, we can use this data to create more outputs later in combination with data lake and data warehouse data.
Now let's go through one of the use case where we can use these predictions to get actionable insight. This is Power BI dashboard used by marketing team. Using this application, marketing team can use prediction data provided by data scientists and play with its attribute to create target customer groups. In this example, let's target who are likely to buy and who are uncertain to buy. Let's select all customer region as is. And now we are going to target customers who are predicted to generate at least 20 transactions and minimum 500 dollars of revenue. So now we got the list of all the targeted customers and for this campaign. Now we can easily export this list to the CSV format and then create an Excel and save it back. So this will use this list will be used by the marketing team to reach out to the customer for the specific campaign. To summarize, in this demo, we have seen how we can transit to modern data analytics systems and build a data lake and data warehouse in Snowflake. Thank you. Over to Jose.
Sunil, thank you so much for those demonstrations. And I do want to point out that we have a limited time here, and we just wanted to give you a taste of the types of things that you could do with Snowflake from the point of view of a data warehouse or a data lake. So let's review the uses and benefits of a data warehouse and a data lake working together. The data warehouse is typically used for structured, conformed, and processed data, and it's typically used for analysis of a specific data set and accessed by a variety of BI tools. The data lake can be thought of as a single repository for all data. You can store structured, semi-structured, and unstructured data. It's highly accessible, and you can update data faster, and it can handle volume, variety, and velocity. Working together, the data warehouse and the data lake can provide many benefits. Some are serving the types of users within the organization, all different types of data consumers, faster onboarding of data sources and data warehouse changes, and there's no need to change existing business data applications in order to do discovery of data. And since we did use Snowflake to point out the benefits of a data lake and a data warehouse, I do have to make special mention of its capabilities. It's a single platform for all analytics consumers. It's SQL friendly. It's in the cloud. In fact, it was built in the cloud for the cloud. It's auto scaling. And as we saw in the demonstrations, it supports semi-structured and structured data. It provides connectivity for a majority of reporting and dashboard tools. And in terms of managed services, there is very little maintenance and administration that's required and is a highly secured environment. So what's next? I'm sure you have opportunities and use cases where you could use the data lake and the data warehouse together. So give us a call and we can discuss your data lake and data warehouse needs. Then go ahead and engage with us to identify a business challenge that requires the collaboration of a data lake and a data warehouse. And finally, let's deploy your data lake or data warehouse or both in Snowflake and work with us to make that a reality for your organization. So on behalf of Sunil and myself, thank you for joining us in this webinar, and we will make the recording available on our website as well as YouTube.